last and final team to present this morning will be Oladipo Johnson, who will be currently working for DKV once he graduates. And yours truly, Dustin Krakowski, who is currently working at Dunham. We will be presenting on power system analysis, ATS sizing, generator sizing, UPS and PDU sizing, and estimation. I'm going to start here off with power tools for Windows. This is a general layout of the industrial building one-line diagram. Over on the left here is our mechanical panel 1, and then serving all the mechanical equipment on the first level. Next to it is the mechanical panel 2, serving all the second level and rooftop units. Next to that is the lighting panel, and then below circuit breaker, cable, bus bar, which is the panel itself, and then the load for that lighting panel. And I'm going to show a low view of one of these here in a minute. And then next to that is the receptacle panel, and then the 480 busway, 208 busway, and then some of the mechanical equipments that are hooked up to the switchgear itself. And then we have our electric utility coming in right here, and then our 2 generators, generator 1, generator 2. And then off to the right here, we have our ATS, which is powering the emergency panel. Now I'm going to zoom in on the electric utility diagram. For the input data that we did on the electric utility, if you were to go into Power Tools Windows SCAM and actually double click on this icon here, up would pop this menu here that you can input your data for it. For the input that we did was the utility contribution of 60,000. And then for the line to ground, we did half that, which was 30,000 amps. And then obviously running at 480 voltage. And then second here is the cable. This is another input device that I'll show where you can click on that button icon to place it in Power Tools for Windows. We there's a button here for the library. Up would pop all the different conductor sizes and types that you can input into this data. We came up and we put in a copper conductor type, non-magnetic, running PVC, insulation is THWN, and then we are running 4 conductors with the conduit. And then based on NEC 310.15b16, the lady who got married and changed her name, we sized our 4,000 amp circuit breaker to be 11 sets of 500 KCM, and we're running that at 60 feet. And then just below it here is our circuit breaker. That is a 4,000 amp Magnum DS draw circuit breaker. This is the balanced summary of the voltage drop and load flow. I'm not going to run through everything here, but just to highlight a couple things here. Our computer room cooling unit, if you move over to here, it's running at a voltage drop of 0.7. And then another big one here is our switch gear. The voltage drop for that is 0.25. So not much volt drop happening there. Moving into the fault analysis summary. Just one that I want to highlight here is the switch gear. It's running at 480, and the available fault current that breaker can trip at is 62,735. And we set ours to 4,000, so you can tell how big we can get that fault current to trip. These are some input tabs that Power Tools for Windows has to offer for us that we can insert, make our one-line diagram, and run analysis on. Up top here is our TCC curve. We can run our all of our TCC curves, breakers. I'll show you that in a minute here. We have our little cable diagram. These two here are our induction and synchronous motors. We have our UPS system, and then our two breakers, or current protection device and fuses, circuit breakers for those. This is the curve I was talking about. This is the chiller curve. Based on coordination for it, we had, it looked a little different when we first pulled it up, but part of the process of coordinating it is to make sure that your circuit breaker or your chiller is close enough to the mechanical equipment itself, so it doesn't, so it does trip if current gets high enough for this equipment to burn. And then, otherwise, if you were to leave it more like out in this area here, the equipment may just keep on running and may never trip. Then the input data that you can put in here is long time pickup. We set that at 1, which is the 4,000 amp setting. The long time delay, we have it set for 24 seconds, so if there were a overcurrent, it would trip within 24 seconds. The short time pickup, we set that at 10. And the short time delay, we set that at 0.5 seconds, so if there was high amount of current happening, it would sense that and sense that to trip within 5 seconds. Yeah, 0.5 seconds. Just a blow-up view of the mechanical panel 2. We have our running circuit breaker here, and then our cable here, and then this is our mechanical panel 2 panel, which is serving some of these air handling units here. I'm going to talk about a little bit about this air handling unit S1. So here's some of the input data we put in on that motor load. We have 480 volt voltage. Our horsepower is 60. Our power factor is 0.8, and our efficiency is 0.93. The curve on the air handling unit itself, like I talked before, wanting to make your circuit breaker so that it coordinates close enough to the mechanical equipment as possible, so no overcurrent, it'll trip faster. And this is the circuit breaker for the mechanical panel 2, and the switchgear circuit breaker. And then these are just some other analysis that you can run on here. We didn't run, we did the balance system studies analysis. There's other ones you can do: transient motor starting, industrial simulation, harmonic analysis, unbalanced and single phase studies, some equipment evaluation, failed equipment evaluation, arc flash evaluation. There's just so many that you can run here. Moving into the automatic transfer switch that we sized, based on DeWalt 3-12, we based it on a 100 amp panel, which was based off of the emergency panel. Emergency panel that we believe we came up with like 2-4 amps, very small because it's just holding all the emergency lighting loads. So we could have sized up to a 30 amp or 60 amp, but we decided, since it's a bigger building, commercial, industrial, we decided to go up to 100 amp minimum standard. Now I'm going to turn it over to my partner, Oladipo.
Thank you, Dustin. Good morning, everyone. I'm Oladipo. I'm going to be talking on the generator sizing, the UPS sizing, the PDU sizing, and estimation. First of all, I'm going to talk about generator sizing. We make use of Cummins software, and that's just the picture and the version that we make use here, Power Suite version 4.1. When going into the program itself, the software, we have the generals, whereby you put in the information of the owners, the name of the project, and you go further to the parameters, whereby you, since we are making use of two generator sets, we need to parallel them, and we are parallel them at 2, and all other information there are populated by the software itself. The only one that we repeated was 2 generator sets that we want to use. These are the icons for the different loads that we use in the project. This one is representing the light. These are, I believe, is a cooling unit, and these are the models for the motor loads, and all other ones there that they are for other loads that we make use in the project. You just go there and select the type of loads that you want, and you name it. We name this one the lighting panels, and you put in all other information like the voltage, and it will populate the other ones for you. It will give you the running amps, the power factor, and other things. When you are using this software, apart from assigning the loads, which still make yours that we assign the steps to the loads. Why do we do this? Is because we want all the loads to start up at different timings. We don't want every load to start at the same time. So we have to assign the steps to individual loads. And this is what you are seeing right here. And this one is a load for, the step for the icon for the assigning step for the computer room cooling unit 2. After we are done with the assigning of the steps and the loads, there's let me go back a little bit. We have this icon here. You just click on this icon, and it will take you to the generator size and the set requirements, and it will give you the kilovolt amps of the generator that you are going to be using for the project, and the model, and that is the model that he gave us over there, 1500 DFLE, and we came out with 1500 kilovolts amps generator cells. I'm moving now to the sizing of the UPS and PDUs. We have, this is the formula that we use in the calculating or sizing the UPS. And from when you plug in the data for these formulas, you go ahead to DWAT 3-13 to size your UPS, to take the UPS standard over there. And we go further to the overcurrent protection devices calculations. And here, when you get here, when you size your UPS here, by plugging in the parameters, I believe we need to multiply by 1.25 for the continuous duty, and you need to step up. Whenever you check, we want to check the next, the standard for it at netbook 240.6. You go to the next standard up, and we cite the feeders based on code book 310.15b.16, as Dustin has rightly said before. And we go to the PDU. We have 2 PDUs, being fed from the UPS, and I'm just showing the one of the calculations for the PDUs. And the formula is almost the same thing with the UPS, and you go to DWAT 3-13 to take the next standard of KVA for the sizing of the PDU. And when we go to the of our current protection device. We made use of, according to the code book 450.3 B or A, depending on the one that you're going to use, is going to give you the percentage there. And I believe this one gives us 2.5%. I mean, no, 250%. So by the time you juggle the figures, we are going to multiply the value here by 2.5. So it's going to give us the amps, and we go to 240.6 to size the generator. But this time around, instead of going up in the UPS on the PDUs, we go to the next standard down, and that's what we did. And the feeders the same way with the code book 310.15.16, and we are able to come out with the size 2 sets of 350 kcm THHN. This is the next one is our project estimation. We make use of my Cummins, and here is the overview of the icons that we are familiar with when you go to the software itself. Here you can label. That is for the steps for the labeling, whereby you can put in your the fixtures that you make use, the wire sizing, the wire lengths, and that one will help us. I'm sorry, here when you click on the labels, it will take you to here, and this is for commodity, the fixtures types that we use. It's going to do the counting for you, and when you click on L probe, that one is going to do the length counting for you. And whenever you click on any of the assembly, there's assembly icon here. When you click on the assembly icon, it will take you to the wire, the copper. You choose the wire size you want, the type, whether it's copper, then you go to the whether it's solid or stranded. Go to the type of the wire. When you click on it, you now transfer the length of the wire through the L probe, and it will now go down and populate it for you under the review menu. And this is the extending and the totaling of the projects that we do. Here we have the dollar per 100. This is the labor unit expression of 100. We have E for individual fixture, and we have M representing 1,000, or C is representing 100. So here it's telling us that $91.51 per 100 of this is installed, and when you divide this one by 100 and multiply by $91.51, it's going to give you this value. And that is how we come about the cost of installing these categories of fixtures and materials that are shown there. Here we have the bid summary report. I just want to talk a little bit on the overhead. This is our overhead here, which is 10%. And we have the selling price, which is amounting to, when we put in our overhead and profit on the material, 10%, and the tax, then we come up with the selling price of 1.845 billion. And here we have the hourly hour per week. What we use as hour per week is 40 hours for the week. That is what we come out with here. The total hours that we expended on the project is 2,063.82 hours total for the whole project. We have this is still part of the proposal continuation. This is the total percentage for the labor cost. The labor percentage. When you add the total input of each each worker together, it must amount to 100%. And the journeyman here put in 20%, and all other people, we can see the percentage as they work, and we added up to 100%. Here is the hourly rate. The journeyman is taking $40 per hour, and the apprentice one and the other people, they are taking $20 per hour. And this column is representing the total labor cost that we come out with, coming to $86,681.38. And this one now takes us to the last portion of the estimation, whereby we come out the repeat summary, and the software will highlight in red the selling price for us here. And this is what we have here. And from the over here, we have the 10% for the labor, and I believe we have this 10% for overhead, which I believe is going to show somewhere here, which I'm not able to put the snapshot over there. That's just what we come out with after the estimation. Any question, please?
What's your direct job expense? Slide 29 had it.
What?
Slide 29.
Right here, no.
No, you were just on it.
Right there,
Right in the
3750.
What is that capturing? What is direct job expense in your estimate?
Sorry. Please answer the question again.
Down in the lower left corner, no, stay there, stay there.
You're on that slide 29 track.
Down below,
Yeah.
direct job expense.
What would be an example of what you would include in direct job expense?
This is it. 3,750.
A lot of people, what did you put in it? What was there? Remember what the info that you put there as a direct job cost?
Trailers,
Yeah.
trailers,
Toilet paper.
tools, yeah,
These pencils.
cell phone use, things like that.
Coffee,
We put 5,000.
coffee, plenty of coffee.
We put 5,000 for the direct job
Sure.
expenses. We put 5,000.
If you go back to your bid summary, I think it's maybe the last, yeah. Yes. It shows total return of 4.81, primarily because you don't mark up supplier quotes, subcontractors, direct job expense. Just a thought, you need to have more than 4.81 return in your jobs. But.
It should be low.
Yeah, you get a lot of work done. We use McCormick, and it is, that total return is misleading, because if you, for example, direct job expenses, that 3750 is made up of a marked up number, it's just a plug number, and you don't mark it up, it drives that percentage down. And the other thing, you need to make sure that you click on your tax tab, and that you added tax to all of your taxable materials and so forth.
Thanks.
Okay, well, thank you guys. This is, as you can see, this will be the last presentation for this 25,000 square foot. It's really interesting to hear about the whole estimating. You've seen they have used a lot of softwares. Well, we always tell guys, when we send them to you as an industry, they are only trainable. They know enough to be dangerous. So I wouldn't trust with $1.9 million for this project. I would not trust that one to get the job or not to get the job. So the whole idea, guys, of this program is to expose them to so many programs so they can utilize in the industry, from estimating to analysis to design and so forth. When they come to you, you can hopefully tweak them a little bit with the estimating. Estimating, I know a few of our contractors are interested. We will be, next year, we will be doing AccuBid as well as McCormick. So from feedback from the industry, they want us to do AccuBid, so we went to a training for AccuBid, and it will be running next year. So that's what I want to say. We have 10 students. 9 of them are working right now for engineering firms and electrical contractors. The one who's not working has a couple of interviews next week, so if anybody wants to grab him, he's for grab right now. So we have more jobs available than we can fill, so that's really good news to have. So that's what I would like to share with you guys. The other thing I would like to tell you is everything that you see, that you saw today, and all the presentation that we do at Dunwoody is on our YouTube channel right now. It will be loaded tonight. So you're going to see the whole presentation as well as video format and digital format on YouTube channel. We have done that, guys, for 3 years right now. All the lectures that we do, I know probably, Tim, you were looking at PDUs. I was so scared about you guys when we look at PDU sizing and UPS. I said, please don't ask about these. How to size PDUs and UPSs. The way we use it is on the YouTube channel, all the lectures. So I really, really appreciate any input, guys. I consider myself jack of all trades. So we go from estimating all the way into design and analysis. So if you have a chance to look at our lectures, we have close to 600 hours as of today. If you guys don't have anything to do, you can watch 600 hours. It goes from lighting calculation into power system analysis, coordination, Revit, and so forth. So it's really interesting. Hopefully, it will be a resource for the industry, for our students that they graduate from here and get back to just review some of the stuff that we do. I think that's all we have. I invite you guys to look at the project. What we do is we have a capstone project. We do 3 of them. You're looking at 1 of them. So all the students have done every aspect of the project. They documented these aspects into a binder like this. So when they come to you for a job interview, the ones who are interviewing, always ask about this capstone projects that they do. It's a complete documentation of what we do in the department. The last thing before I'll let you guys go, we are moving into the semester. That's kind of putting my hat as a manager. And I would like to share with you the new format of ECDM, how it's going to look like in a semester. And I would like your feedback if you guys have a chance, not now, when you have a chance to read through it. So this is how the program is going to look like, and I can summarize it for you. So here you go. Well, this week, what we did, because of resources and to consolidate everything that we do, we grabbed the first year and we aligned it first year ECDM with first year ELEC. So when our students will come, they will learn the basic electricity, hands-on, bending conduits, wires, and motors, and so forth. And also we'll teach them Revit and AutoCAD in the first year. When we move to the second year, we will continue doing 3 projects. As we have done in the past, we will do the industrial project. You're watching it today. We will do the commercial project, which is 12,000 square foot, the same thing that we have done it. And we will do a residential project, which is 5,000 square apartment building. The only thing we did in the second year is we grabbed all the estimating to do a better job at the estimating and the project management, and we provided 2 classes that's going to be dedicated for estimating and project management from a contractor's point of view. That's where we're going to be going deeper into AccuBid and McCormick and project management. So that's 2 classes that will be dedicated for AccuBid, estimating and project management. So that's basically what we did. These are the classes how it will look like. We look forward, guys, to any feedback that you have about anything we do. And I think that's all what I have. I would like to take a few minutes to congratulate our students for the graduation. I'm so proud of them. If you see what I see when they come to us, like Gary said, day 1, and then when they come to me, and sometimes we wonder if we're going to reach the destination, but they always, as always, amazes me how good of a job they do. It really is. It's amazing. It's a lot of things that we throw at them, and I always say this is a great industry, and you can the limit is the sky and how far you can go in this industry in the design or the construction. So Congratulations for the grads, and thank you.